Hello everyone, welcome to Unacademy, India's largest online learning platform, which is helping the students of all walks of life. Good evening, Satish. Good evening, welcome. Good evening, Satish. Good evening, welcome. Okay, so today is going to be the 7th lecture on electronic devices and circuits, right? So we'll move on then. Myself, Shravan Kumar, as you all know. So I have 10 plus years of, I have master's degree from JNTH in VLSI system design, and I have 10 plus years of teaching experience, and then I have, so I can take the subjects like EDC, Analog Electronics, Digital Electronics, and EMFT. I have a special code for all you guys, that is SVS10, which will help you to get the 10% discount on plus subscription. And you guys know what do you mean by plus subscription. A plus subscription will give you access to the live classes. You can attend all the crash courses. We'll be having weekly tests, and then double doubt solving sessions will be there. And you'll be given lectures in English and Hindi. Somebody who don't understand English, they can listen to Hindi. And we have something called rank improvement batch. This will also help the students to improve their rank. And this all comes under plus subscription. Then we have something called iconic subscription. So what do you mean by iconic subscription? Raviteja, good evening. Raviteja, good evening. Welcome. So we'll be having a personal coach. You'll be given a personal coach. We'll be having a study planner. You'll be given a study booster sessions, and then you'll be given a personal test analysis, and a preparatory study material will be available. Right. So this is the free structure for plus subscription for 12 months, 18 months, and 24 months. You guys already know it. So 39,600, 34,650, and 27,220 rupees. And then for iconic subscription for 12 months, it is 45,225 rupees. For 24 months, it is 66,600 rupees after using this SVS10, which is a 10% discount. Harika, good evening, Harika. Harika, good evening. And you know how to download this, right? So you'll be having Unacademy GATE subscription. I mean to say, you can download Unacademy app, click on install, then you will be asked to select your goal. You have to select GATE and ESE, and then you should click on plus subscription. If you click on plus subscription, you will be taken to something called GATE subscription page. The new page will be opened, and here you can have a 12 months and 24 months subscription. Select 24 months, whichever you want, and click on, but don't forget to type SVS10 to get 10% discount on it, and click on apply. Then you will be given some amount, and click on proceed payment. You'll be having many payment methods. You'll be having debit card, credit card, EMI, UPI, wallets, net banking. So you will be having many things. Okay. Then, sir, very important thing comes here is, so we'll be having an Unacademy combat test. This combat text, sir, for those who are attending, sir, this is very important. Please listen. Don't skip this. Very important, sir. Those who are attending GATE 2022 and 2023, sir, this is very important for you, sir. This is going to be an Unacademy combat test, so which will give you 85 lakhs plus in this month of February, sir. Right? We'll be giving scholarship of 85 lakhs plus. So this will be on 28th of the February from 11 a.m. So, but you should use the code SVS10. You should use the code SVS10 to get 10 to enroll yourself. And scholarship pool not existing. So this is not for the existing subscribers. This is for new subscribers, students like you. So this is a free scholarship test, and this will be there on 28th of February at 11 a.m. That is Sunday. Coming Sunday, we'll be having this 11 a.m. So use this opportunity. Please use this opportunity to get this, to get Unacademy combat and scholarship test. So what you will get here is you will be having this is for EE, electrical engineering, and ECE students. So which will be there on 28th of February, as I told you. This will be only 60 minutes test, 60-minute test, And top 3 winners from each branch will get 100% scholarship on plus subscription. So just now, as I told you, so plus subscription fees is very high. So but you will be given 100% free scholarships for plus subscription. Okay, but you need to use the code SVS10 to unlock the code, right? So use this opportunity. To get more and more, sir. To get more and more. And so the terms and conditions with scholarships need to be availed within 7 days of the scholarship test. Okay, scholarships will only be offered on the 6 months and higher duration subscriptions, right? So the scholarships will only be offered on plus subscription, not on iconic subscription, right? No additional code based discount can be applied on top of these scholarships. So these scholarships are not available to the existing subscribers. A free learner can avail a scholarship only once in 180 days. Only once in 180 days. It means in 6 months you can attend. Sir, seriously, this 1 hour you spend and you'll get very, very good opportunity, sir. Right? So for rank 1 to 3, a complete 100% free subscription for the tenure of your choice. Whether it may be 6 months, 1 year, or whatever you want. 100% complimentary will be there for rank 1 to 3. From rank 4 to 10, it will be 75% off. 75% off on Unacademy plus subscription. And for rank 11 to 50, you get 50% off. And from rank 51 to 100, 25% off. 25% off. So please use this opportunity. Please use this opportunity to crack the exam and get into this important plus subscription, sir. Yeah. Now coming back, now we will start discussing about our today's topic. So if you can remember what we discussed in the previous class. I'll quickly recap what we discussed in the previous class, just for 2 or 3 minutes. Then we'll come back to this topic. We'll come back to this topic. Okay. So we have discussed very important theory, that energy band theory of the crystals. We have discussed the basic how the energy bands are formed. How the energy bands are formed. This is the very, very important concept we have discussed. Hope all of you understood the concept very clearly. If anybody asks you how these energy bands are formed, you can easily say about this right now. So you must be able to answer what do you mean by valency shell, or valency band and conduction band. What is energy gap? All these concepts are discussed in detail. Yes or no, sir? Did you understand? Did you guys understand or not? Did you guys understand very easily or not? The energy band theory was a very, very important concept, and we have seen whenever interatomic states, interatomic distance is decreased. Now you have seen here is initially you will be having 2 n states of s orbital, 2 n states of s orbital and p orbital will be filled. S orbital will be completely filled, but whereas p orbital is only filled 1/3. Only filled 1/3. Only filled 1/3. Okay, but then whenever the interatomic distance is decreased from 10 micrometers to 5 micrometers, you can see here the spreading of the energy levels is happening. The spreading of the energy levels is happening. So if you further decrease here, now what happens, sir? The overlapping of energy levels will happen. Overlapping of the energy levels will happen. And if we still further decrease, so for 1 micrometer, now what happens, sir? All the filled states will come into one area. All unfilled states are coming into another area. Right? Filled states, and these filled states are called valency band. All the energy bands which are filled with electrons, is called valency band, and the energy states which are unfilled states are called as conduction band. And the gap between these two, the gap between this conduction band gap between this conduction band and valency band is called forbidden energy gap. Forbidden energy gap. Did you guys understand or not? So this is our focus point yesterday. This was our focus point yesterday. Okay. And I think we have discussed in detail about only that. And we have discussed what is energy band also. And then we have started discussing about what is an insulator. What is an insulator? And then the insulator is a very poor conductor of electricity. And we have seen the energy gap. So now our complete classification of the materials, our complete classification of materials is based on the energy gap only. There are three types of the materials which are available: insulator, metal, and semiconductor, or I can call insulator, conductor, and semiconductor. Are you guys understanding or not? Are you reply de do na? Are you sleeping or I am sleeping? Please reply me, yaar. And the examples of insulator are wood, plastic, glass, and diamond. Wood, plastic, glass, and diamond are the examples of insulator. And we have seen the energy gap is 6 electron volts. And for a metal, the overlapping of valency band and conduction band will happen. Overlapping of valency band and conduction band will happen. Right? So, and what is the energy gap for metal, sir? For the energy gap, there is no energy gap also, sir. There is no energy gap at all. Arika, you understand? So there is no energy gap at all. There is no energy gap at all. Okay, so there is no energy gap at all for a metal, right? So full conduction of electricity will happen in metal, and we have come a semiconductor. Sir, my focus point is this today, very important. Now here we have come to the original point of discussion. So far what we have discussed, correct Satish, you're right, zero is the energy gap, correct Satish? So the semiconductor is a major important concept which we have to understand now. So the energy gap of semiconductor is neither high nor low. Not like a metal, not like an insulator. It will be in between, and where the electrons in the valency band can gain some energy and they can go to the conduction band. That type of materials are called semiconductors. That's what we discussed, I think. Okay. So now we will see here. Now today's class, I don't want to cover again this insulator, metal, semiconductor, but semiconductor is a more focus point. More focus point, sir. So the energy gap of a semiconductor, is going to be simply 1 electron volt. Simply is going to be 1 electron volt. Okay. So now what are the examples of semiconductor, sir? Examples of semiconductor are germanium and silicon. Germanium and silicon is the major important semiconductors for us. Major important semiconductors for us. Okay. So germanium and silicon. Why germanium and silicon are only semiconductors? Why don't we have others, sir? This is the fourth group of elements. Of course, they are the fourth group elements. Germanium and silicon are fourth group element. We have carbon also a fourth group element. Why carbon is not a semiconductor? That anyway, just give me some time. I'll come back to that point. Why carbon is not a semiconductor? I'll definitely come back to that point. But meanwhile, remember the germanium and silicon had the energy gaps of a germanium. Energy gap of a germanium is going to be 0.785 electron volts. Simply 0.785 electron volts, and whereas the energy gap of silicon is going to be 1.21 electron volts, and these two are at 0 degrees Kelvin, temperature. So the energy gap of a semiconductor, especially for germanium and silicon, is going to be 0.785 electron volts for germanium, and silicon is going to be 1.21 electron volts. Okay, right? This is very important. Now, but remember, very important point here. At 0 degrees Kelvin, this is the note which you should remember, sir. Many times in the previous GATE examination, they are asked at 0 degrees Kelvin, germanium and silicon acts as germanium and silicon acts as what, sir? They act as an insulator. Acts as an insulator. Remember this point. Insulator. Why, sir? Why, sir? Why they act as insulator at 0 degrees Kelvin? Can someone tell me why? Because the energies of this energy gaps cannot be acquired by the electrons at 0 degrees Kelvin. At 0 degrees Kelvin, the electrons in the valency band cannot acquire this much amount of electron volts energy, and they cannot go from lower energy level to the higher energy level. That is, from valency band to conduction band, they can't jump. So because of that reason, this at 0 degrees Kelvin, germanium silicon acts as an insulator. But as the temperature is increasing, remember this point, as the temperature increases, the energy gap will decrease. As the temperature increases, the energy gap will decrease. And now what happens, sir? When the energy gap is decreased, so simply assume that you want to jump your college wall. You want to bunk the classes. So most of you generally bunk the classes, right? You will go out of the college. Right? To watch some mass bunk or to watch some films or to those beautiful days of your college days. I mean to say, now there is no college at all. Everything you are occupied at home only. But in your olden days of college bunking, right? What you'll do, sir? Generally, you'll jump the wall, right? And you will see, where the wall's height is very small. You will choose the wall. Where its height is very as low as possible, and then you will jump from the wall. Yes or no? Similarly, electron will also same. As the temperature increases, the energy gap of valency band and conduction band will decrease. So when the energy gap of the valency band and the conduction band decreases, now electron can easily jump from lower energy level to higher energy level. That is from valency band to conduction band. Okay. This point you should remember. Okay. Then, so there is one more point which you should remember here, right? The conductivity increases or temperature increases. So now you should remember. I should tell you conductivity increases as the temperature increases. Why, sir? As temperature increases. Why? How and why? Very simple, sir. Very simple. As the temperature increases, So you know that many electrons are present here. Electrons are present here. This we call EV is a valency band, highest level of valency band energy. This is going to be EC, conduction band. This is conduction band. So when the temperature increases, the electrons which are present here will gain some momentum, right? As the temperature increases, the valence electrons acquire some thermal energy. We call it as a thermal energy. When these electrons gain thermal energy, now it is easy for them to jump from valency band to conduction band. It is easy for them to jump from valency band to conduction band. Okay. And once they come into the conduction band, now they are free for conduction. Free for conduction. They are free for conduction. Okay. Now here the electron Jessima, you are saying something also. You are talking about thermal voltage. Okay. VT is equal to KT by Q. That's what you are talking about. Okay. That also we'll discuss, Jessima. That also we'll discuss. No problem. Right? Now you understand now. So far I was talking about only electron. Did I ever use the word hole? No, right? Here comes the story of hole. Correct. Jessima, you're right. Jessima, you're right. Understood. Okay. Come back to this thing. So far I was talking about only electron. I did not talk about any hole, any word hole. Now I'll talk about this. Whenever the temperature increases, as I told you, this electron will gain some thermal energy, and because of that, they'll move from valency band to conduction band. Now what will happen, sir? When the electron is moving from the conduction band to valency band to conduction band, it creates something called hole. And now I'm going to call this as a hole. So what do you mean by that? Absence of an electron. Remember this. There is no concept of hole at all. You can't see a hole at all. But the absence of an electron in a valency band. Actually, I should use a word covalent bond. I'll talk about once we discuss about covalent bonds. Remember, there is nothing called hole. There's only electron is present. But the absence of as we know, what do you mean by darkness? Sir? Absence of light is darkness. Light is darkness. Similarly, absence of electron is called hole. Remember this point. So there's nothing called hole. Is the point clear? Okay, there's nothing called hole, but the absence of an electron is called hole. So whenever electron is moving from valency band to conduction band, it leaves a hole. We call it as a hole is created in the valency band. Okay, the absence of electron in the valency band is represented by a small circle. It's a small circle you can see here, and that is called as a hole. Okay. Right. So now the important thing you should remember here is so Simha, your question is right. Do you see the darkness? What do you mean by? See, if you feel that the darkness doesn't exist, it doesn't exist. If you feel that darkness exists, it exists. Similarly, if you feel that hole exists, it exists. If you feel that there is no hole at all, you will not exist hole at all, because absence of light is darkness. Absence of electron is a hole. Absence of electron is a hole. Remember that point. Absence of electron is a hole. Okay. Now the important thing here is, now how does the temperature changes the energy gap of silicon and germanium? Energy gap of silicon and germanium. So the energy gap of, I'll write with some other color so that you will guys. So the energy gap Eg of a silicon, energy gap of a silicon is equal to, generally what is said is 1.21 electron volts, 1.21 electron volts minus 1.21 electron volts is generally when it is 0 degrees centigrade, right? So whenever the temperature increases, now it will decrease, yes or no? Energy gap is decreased. That is 3.6 into 10 to the power of minus 4 into T electron volts is what? The energy gap of silicon. Similarly, what is the energy gap of germanium, which vary with the temperature, is going to be 0.785 minus 2.3 into 10 to the power of minus 4 T electron volts. So these are the two important formulas. Generally, some questions will be asked based on this. Okay, so remember these two formulas. If possible, we'll also do some uh, uh, some problems based on this, if you guys are interested. Okay, now if these two are the formulas to be remembered, so now tell me what will happen at temperature T is equal to 300 degrees Kelvin. That is room temperature. At room temperature, what will be the energy gaps of these two silicon and germanium? So at room temperature, that is 300 degrees Kelvin. 300 degrees Kelvin. So the energy gap of silicon, is how much? Can somebody tell me? If you know, it's going to be 1.1 electron volts, and the energy gap of germanium, is going to be 0.72 electron volts. 0.72 electron volts. Okay. So energy gap of silicon is going to be 1.1 electron volts, and energy gap of germanium is going to be 0.72 electron volts, because it has to decrease, right? So it is decreasing from 0.785 to 0.72. So now the electron can easily gain the some energy, and it can easily go to the next level, conduction band. Okay. Okay. Hope you got all the points. Now tell me why carbon is not a semiconductor, though it belongs to the fourth group element. Why carbon is not a semiconductor? Why carbon is not a semiconductor? Tell me, why carbon is not a semiconductor? Why carbon is not a semiconductor? Do you know, guys? If you know, let me know. Otherwise, I'll tell you. Why carbon is not a semiconductor? You tell me tomorrow, right? So you just tell me why carbon is not a semiconductor. You just tell me tomorrow. Consider this as a homework and tell me tomorrow. Right? The orbital model of now here originally it comes to the original concept of orbital model of silicon atom. So what is electronic configuration of silicon? What is electronic configuration of silicon? Silicon is going to be 14. We can write 1s2, 2s2, 2p6, 3s2, 3p2. Yes or no? 1s2, 2s2, 2p6, 3s2, 3p2, 3p2. It means I'll just try to draw here for all our convenience. For all our convenience, I'll try to draw it here. Just pay attention, sir. Just pay attention for a few minutes. This is very important to be remembered. This is very important to be remembered. That is the reason why I'm just trying to pull it again and again. Very important, sir. Very important. If you understand this concept, this is very important. Orbital model. Orbital model is very important. Orbital model is very important. Orbital model is very important. Very important. Did you guys know this? Did you guys know this? Know about this? Orbital model of an atom. Orbital model. Just pay attention. Just pay attention. Don't. You're just looking for something, some other color. Is there any other color? Arey yaar, just a second. Yeah, I'll do this. It's gray. Okay. Now remember, assume that this is going to be the nucleus. This is going to be the nucleus. So obviously, how many? What will be there in the nucleus, sir? What will be there in the nucleus? What will be there in the nucleus? We'll be having this nucleus will consist of. The nucleus will consist of. So I will call this. I'll call this as a nucleus. Better I'll do it with green so that you guys will understand. We'll be having something different. So this is called nucleus. This is called nucleus. Okay, so which will be having 14 protons and neutrons. 14 protons and neutrons. And then this is the 1s2 orbital. This is going to be 1s2 orbital. This is going to be 2s2, 2s2, 2p6, 3s2, and then 3p6, 3p2, 3p2, 3p2. It means what does it mean, sir? What does it mean? So here you will be having only 2 electrons, 3p2, 3p2, and 3s2. He also will be having only 2 electrons, 3s2, and then you will be having next. It is going to be 3p6, 2p6, 2p6, 1, 2, 3, 4, 5, and 6 you will be having, and then here you will be having 3s2, and still then you will be having 2 more electrons here in 1s2, 1s2. So understand this, sir. Understand this. So this is the last one. The last one here is. I think I'm unable to do that. So this is the these blue colors are called valency orbitals. These are valency orbits. Valency orbits. Remember this. These are called valency orbits. Valency orbits. Okay, right? So then these are called inner orbits. These are called inner orbits. This red one. These are called inner orbits. Inner orbits. Okay. Then this is called core orbit. This is called core orbit. This is called core orbit, right? Now, sir, really it give a clear picture. Very thank you, sir. Okay, Satish. Okay, and then so then tell me what is this last one? Can somebody tell me what is this last one? Can somebody tell me what is this last one? Satish, I am here to clear all your doubts. My job is that. My job is that. My job is that. You not worry. You can ask me any questions also if you want. So you never worry. You never worry about asking questions. I am here to answer your questions. Okay. Always feel free to answer the questions. Right? Sir, this last one is what, sir? So I told you this is going to be valency orbits. Valency orbits. These are inner orbits, and then the core orbit I called, and then we have something called nucleus. It's called something called nucleus. Then what is this last one? This is very important. This is what we call it as first excitation orbit. First excitation orbit. First excitation. This is called first excitation. What do you mean first excitation? First excitation orbit. First excitation orbit I call this as. So what do you mean by first excitation orbit? Harika, you are right. Harika, you are right, Harika. It means the electron, the outer valency electron, whenever it gains some amount of energy, right? So far we have discussed, right? So whenever this electron, this is these two are electrons, 3p2 I am talking about, 3p2. So this and this electrons, these two electrons will get some energy and they'll go to the next energy level. And that energy level is called the first excitation orbit. That energy level is called first excitation orbit. Okay, if the energy, if the electron gets more energy, then it will revolve around the nucleus in the another orbit called second excitation orbit. Second excitation orbit. Okay, so this is very important. This is very important. Okay, so first excitation orbit, second excitation orbit. So this is the orbital model of silicon. Sir, I can't discuss about germanium because germanium has many orbits. So I'll stop my discussion here because it's going to be 3D10, 4s2, 4p2. I should right. So that will create a lot of fuss here. So I'll stop it here. Hope you understand the orbital model of silicon atom. This is very important, sir. This is very important. Okay. Okay. Shall we go to next topic? Shall we go to next topic? Next topic is also very important topic. Next topic is going to be very important topic. So silicon has 1s2, 2s2, 2p6, 3s2, 3p2. This is what, this is the first exit. There is no orbit at all, sir. But the electron which gains some energy will go to this orbit. It will revolve here. And that we call as first excitation orbit. First excitation orbit. Okay, clear? Okay then. Next, here comes the original story. So what are the types of semiconductors? How many types of semiconductors are? There are two types of semiconductors. There are two types of semiconductors originally. There are two types of semiconductors originally. Can you please tell me? Hope you guys know it. Right, delta is equal to E2 minus C1. Why the sum delta? Acha, you are talking about if we gain some energy. Okay. Right. You are right. I understood your point, Raiteja. You are right. Delta is nothing but E2 minus C1. Change electron energy. Okay, no problem. Now tell me what are type of semiconductors? Yes, there are two types of semiconductors. There are two types of semiconductors. One is called intrinsic semiconductor, or we call this as a pure semiconductor. We call it as a pure semiconductor. And then we have next is called extrinsic semiconductor. Extrinsic. Sir, many students will have a doubt. Many students will have, Ratija, you are right, Ratija. Many students will be confused with this. Many students will be confused with the names of intrinsic and extrinsic. Just wait for 2 seconds, 2 minutes. I'll clarify your doubt. You will never forget in your life. So what do you mean by intrinsic? What do you mean by extrinsic? And these extrinsic semiconductors are again of two types. These extrinsic semiconductors are again of two types. You know what are they? You know what are they? They are called N-type semiconductor, N-type semiconductor, and then we have something called P-type semiconductor. We have something called N-type and P-type semiconductors. So these extrinsic semiconductors are also called as impure form of semiconductors. Impure. They are called impure. They are impure. Sir, remember in your life, never forget that extrinsic. Sir, this extrinsic is nothing but external. External. So when you add some external atoms to the pure form of semiconductor, then this new form of semiconductors will be formed. You remember this extrinsic means externally some impurities are added. Externally some impurities are added. Because of that, it's called extrinsic semiconductor. Okay, because of that, it's called extrinsic semiconductor. So always intrinsic means pure and extrinsic means impure. And we'll talk about something called doping also. We'll talk about doping. Remember, whenever you add a pentavalent atoms, pentavalent. What do you mean pentavalent, sir? Pentavalent atoms. When you add a pentavalent atoms, a new type of semiconductor will form. That is called N-type semiconductor. That is called N-type semiconductor. And then P-type semiconductor is nothing but trivalent impurity. When you add a trivalent impurity, then we call it as P-type semiconductor. Okay, remember this. Just remember this. We'll discuss about this extrinsic and intrinsic in detail. With some problems also. Which is very important. For us to discuss. Okay. Now, remember there are two types of semiconductors, intrinsic and extrinsic semiconductors. Extrinsic semiconductors are again classified into two types. That is N-type semiconductor and P-type semiconductor. Pentavalent semiconductor or trivalent semiconductor also you can call. Okay, is the point clear for all of you? Before further proceeding, we need to understand how these charge carriers will be moving in semiconductor. Correct, Satish, you are right. Yes. No, it is not atoms. It is electron. Satish, it is an electron, not an atom. Okay. Now so far what we discussed, we have discussed that there exists some electrons. And we have seen what is the type of semiconductor. Our next discussion will be focusing on how these charge carriers will move, or how this electron will transport themselves, how they are moving from one area to other area. Sir, if you listen to my first class, I have told you that the whole concept is all about the flow of charge carriers, the flow of electrons, right? What is electronic device? Electronic device is a semiconductor device in which electrons flow will happen. Right? That is the more major important thing now we should discuss. Now that is the most important thing which we should discuss. What is that, sir? Transport phenomena. Transport phenomena in a semiconductor. Now, till now we discussed about the types. Now, then important thing is the transport phenomena in a semiconductor. The transport phenomena in a semiconductor is now important. Okay. The current in a metal is due to the flow of negative charges or electrons. Remember, in a metal, the current is exclusively because of electrons only. Remember this point. In a metal, the current is due to just because of electrons. The current is because of just because of electrons. But in case of semiconductors, and some remember, electron is always called as a negative charge. Electron is always called as a negative charge. Electron is always called as a negative charge. Whereas the hole is called, a positive charge. I'll let you know why a hole is called a positive charge and why electron is negative. That we will discuss later. But we have seen that the energy of an electron is negative. Yes or no? In our previous class, we have discussed, we have come to a conclusion that the charge of an electron is negative. The charge of an electron is negative, right? But where now assume that the charge of a hole is a positive charge. The charge of a hole is a positive charge. Now, here in case of a semiconductor, the current is because of both charge carriers. Both charge carriers, they are negative charges and positive charges. Negative charges or positive charges, but either of them will be predominant. It means one of them will be giving more current than the second one, depending on the type of the semiconductor material. So either electrons will be giving large current when compared with whole current, or holes will be giving large current when compared with electrons. But remember here the conduction is because of both. Both. You remember this, both electrons and holes. Current is because of both negative charges and positive charges. That is electrons and holes. But either of them will be predominant. Okay, remember this. The transport of charges in a crystal under the influence of electric field and also as a result of non-uniform concentration. Now you understood here. There are two types of charge transportation will happen. The transportation is because of two ways. Either because of the electric field, external electric field, or because of non-uniform concentration gradient. So what do you mean by concentration gradient? What, sir? I simply explain you a simple example. I'll explain you a simple example. Right? Let us say all students are standing outside the class. All the students are standing outside the class. Right? When the faculty wants to come to your classroom, what will happen, sir? All the students will get into the class. It is because of the force. Yes or no? It is because of the force. Because here the faculty is an external electric field kind of thing. All the students are getting into the class because of the faculty who is coming to teach you. Because of the teacher who is coming to teach you. Right? Second condition. Faculty is not there, sir. Let's say your classroom is having 20 benches. Let's say on right side you have 5 benches, and left side you have 5 benches. If If many students are sitting on the right side of or left side of your class, what you do, sir? You will feel that let me go to the other area, let me occupy other seat, right? If 10 students, let's say you have 10 benches, 40 students are there. 10 benches are there, 40 students are there in the classroom. In the first 5 rows, let's say all 60 students, all the 40 students are sitting. All the 40 students are sitting. Then what happens, sir? Slowly, what will happen, sir? Few people will go to the empty benches, yes or no? Empty benches, yes or no? That is nothing but a non-uniform concentration. That is called concentration gradient. See, these two transportations, because of the external electric field and a non-uniform concentration gradient, these two will be having two different names. They are called drift and diffusion. Drift and diffusion. Remember, drift current is nothing but it is because of the external electric field. External electric field. Drift current is because of the transport of charge carriers under the influence of electric field. Assume that the faculty, all the students are entering into the classroom. All the students are entering into the classroom because of the faculty. Because of the faculty. Some external force is forcing you to get into the classroom, to occupy the seats. To occupy the seats. Okay. Is the point clear? Is the point clear? Is the point clear or not? Drift current is because of the electric field. Because of the electric field. Means let's say some charge carriers are here. Some charge carriers are here like this. Anyway, I'll talk in detail about when we talk about a pentavalent or trivalent impurities. But remember, drift current is nothing but the current, the transport of charge carriers in a crystal under the influence of electric field. Under the influence of, I should call this as an external electric field. External electric field. Best example is your faculty. Your faculty. As the faculty is coming to your class, what you are trying to do, sir? You are trying to get into the classroom. That is called drift current. That is called drift current. Okay, drift current. That's called drift current. Now, second case, what I told you, sir? Second case, what I told you, sir? In the second case, what is the second case, sir? I call this as a diffusion. Diffusion. The transport of charges. The transport of charges in a crystal due to a non-uniform concentration. The transport of this is not OD, this is going to be off actually. The transport of charges in a crystal due to the non-uniform concentration gradient. Non-uniform concentration gradient means how it look like, sir? How it look like, sir? Now I'll try to explain you here. The best example I have already told you. Let's say at this point you have many charge carriers. This is like all the students who are sitting. All the students who are sitting. All the students who are sitting. All the students who are sitting in the first half of the classroom. Now, when more number of charge carriers are existing, what will they do, sir? They'll go to the other end. And they'll slowly try to occupy these places. Sir, here also what's happening, sir? The charge carriers are moving. Right? So, what do you mean by current? Flow of charge carriers, flow of electrons. Flow of electrons is nothing but current charge per unit time, right? So here, so whenever the charge carriers electrons are moving from left to right, they form a current, and that current is called diffusion current. This process of transportation of charge carriers without having any external influence, and just because of non-uniform concentration gradient, means the gradient is the charge carriers are high in this region to the left of the screen, and here they are very less to the right of your screen. Okay, so slowly they'll be moving from high concentration region to low concentration, as generally you do it in your classroom. And there also the transportation of charge carriers is happening, and that is called diffusion current. Did you get the point? These two are very important. Many students will have a doubt even when they are writing the exam. Simple exam, I have told you. Remember, drift means faculty. Drift means faculty. The transportation of charge carriers because of the faculty. That is the external force. Is external force. Right? Forcefully you are entering into the classroom. That is nothing but a drift current. And if you are moving in the classroom without external influence of your faculty member, on your own you are moving because of the suffocation. Generally, what is that? I am getting suffocated because of the high crowd in one side. So the faculty will be moving from, the students will be moving from one seat to other seat. That is called diffusion current. Okay. So this is what about two important concepts of drift and diffusion currents. And mobility of the charge carriers we will discuss in tomorrow's class. So tomorrow's class we will discuss about mobility of charge carriers, and current density also we will discuss. Very important. This is current density. Very important. This current density. Please don't miss my tomorrow's class. This is very important. Current density is very important concept to be discussed. And then we'll discuss about conductivity also. And then we'll do some problems based on this. Tomorrow we'll discuss some problems, sir. Tomorrow we will definitely discuss a few problems. This is one problem. I think we have one more problem also. This problem also we will discuss. These two problems, which are very important problem. I think these are asked in the previous GATE examinations. They were asked in the previous GATE examination also. Okay. These two questions we will definitely discuss in tomorrow's class. These two questions we will discuss in tomorrow's class. Okay. Yeah. Okay. Now I've come to the end of the class. So please do subscribe for a plus subscription. So what is a plus subscription? You can attend all the live classes. You can attend all the crash courses. You'll be having a weekly test. So writing weekly test is very important, sir. So as per my knowledge, if you want to get much good score, you have to write definitely a weekly test. Definitely you should write a weekly test. So this is very important. And you will be having doubt solving sessions. So doubt solving, every 4th hour is going to be a doubt solving session. And then the sessions will be in English and Hindi. Those who don't understand English, they can attend Hindi classes. And you have something called rank improvement batch. Okay. These are the benefits of plus subscription. And then we will be having something called iconic subscription. Along with the benefits of plus subscription, you will be having a personal coach. You will be given a study planner. And then you will be given a study booster sessions, and a personal test analysis will be conducted, and a preparatory study material will be given. To all of you. These are fee structures for plus subscription for 12 months is 27,225 rupees. Plus subscription for 18 months is 34,650 rupees. Plus subscription for 24 months is going to be 39,600 rupees. After using the code SVS10. Which will give you 10% discount. Iconic subscription for 12 months is going to be 45,225 rupees, which will give you 10% discount of SVS10. So iconic subscription for 24 months is going to be 66,600 rupees, which will give you 10% discount. Okay. So it will give you 10% discount. So my class notes will be available on Unacademy GATE English. Please download my class notes on Telegram channel. This is the Telegram channel where we will be having Unacademy GATE English Telegram. You can download all the notes. You can download all the notes, and then this is the Unacademy GATE English, is the channel where I am teaching, and we have extra channels also. We have a Creatrix GATE channel. We have GATE for mechanical engineering, production engineers, and engineering sciences. Unacademy GATE for civil engineers and chemical engineers will also be there. Unacademy Computer Science and Instrument IT Information Technology is also there. Unacademy GATE questions is a separate section which you can attend. So we have something called electrical junction also. We have something called electrical junction also. We have something called electrical junction also. So please like the class, share the link, and then click on subscription. Please subscribe and hit the bell icon. Hit the bell icon to get all the notifications of all my classes. Right? We'll catch you tomorrow. So don't miss my tomorrow's class. Don't miss my